In this video, we're going to be talking about different ways you can make a structure strong. We're going to discuss beams and the different types of beams, different types of supports for beams, the truss, the arch, and the dome. So first, we're just going to talk little terms. So when we talk about stability, it's a structure's ability to maintain or regain a stable position. So structures do move with dynamic forces that act upon them and applied forces that act upon them. But stability is their ability to regain a stable position and maintain it. Center of gravity. That's the point where the mass is equally distributed in all directions. Okay. So first we'll talk about beams. A beam is a reasonably level structure that supports a load. So if we think about any kind of construction, we can identify different beams. If we think of a door frame, and you think of the top of the door frame and the load that it holds, and the sides of the door frame and the load that it holds. Because the sides would also support the top, and the top supports what's above it. And so we think about those beams in construction and how they support. We think about the different materials that are used in construction and to make something strong. And, certain metals and certain woods, they're stronger than others. But certain materials can be really heavy. So what we have done in construction, how we've grown and developed in construction, is we've tried to find ways of using certain materials, but adjusting them in certain ways so they're still as strong, but they're not as heavy. So there's not so much load in a structure. So if we think about the I-beam. Now this is a sort of a front view, so it looks like an eye. It would be a long piece of metal, and it would be used in construction and building large structures. And it's made out of steel. However, it's not a solid block of steel, so it's just as strong, but it's not as heavy. So it doesn't contribute to the dead load of the structure. Corrugation. This is where we're bending the material. We see this if you've ever torn apart a cardboard box and you know that there are sort of the two flat pieces, and then inside it looks like the pieces have been folded. So that's corrugation of materials. You've also seen it on roofs where the roofs appear to be bent, and so that would be corrugation. Then there's rebar. These are those metal bars that they're not smooth, they look kind of bumpy. And what they would do is when they're building large walls, like a school wall that is like a solid piece of cement, to reinforce it, they would put the rebars in, crisscross them through, fill that with cement, let it harden. So the rebar is within the cement, and the cement, of course, is has less mass than the steel, but the rebar is steel, so that adds to its strength and its ability to keep a structure strong. And then we have a cantilever. So a cantilever is a beam that has supports on one side attached to its foundation. So if we think about, there's a platform at Niagara Falls, I think on the American side, where people can walk out here, and this cantilever, it's a beam that's only supported on one side. All right. Dropped one. All right. Okay, so there are different ways of supporting a beam. So in these examples here, the red shows my wall. The green is my beam. Here's my beam, my level beam that supports a load. And here's my load. It's a sign. And the load is on one end. And my beam is it's a cantilever beam, so it's only secured on one side. And there's different ways of supporting that kind of beam. One is a tie. A tie is a support on top of the beam, which then attaches to its foundation, which is the wall. This is to prevent tension. So if we think about this sign, the load would pull down on this side of the beam, and the beam would curve. And that's that tension, right? We're spreading apart the particles in the beam. In opposite, a strut supports beneath the beam, so that's it's preventing compression. So again, the load would pull down on this end of my beam, causing that bending, that compression, that squeezing of the materials, and a strut would support that. Then we have a gusset, which is it's put in the tie position, so it's on top of the beam, but it's a solid piece. And it's normally in triangle shape, because we know that triangle is the strongest shape. But it would be a solid piece of material. And again, it's to prevent that tension and compression, but it's above. So that's ways of supporting that cantilever beam. Now we're getting into sort of larger construction. So this construction is the truss. Now the truss is a network of beams. So each one of these lines here represents a beam, and they're in a triangle formation. We see this in bridges over water. You see this in home construction and roofs, because that supports the load of rain and snow and other dynamic forces. And it's one of the, and it is, a triangle is the strongest structure there is in building. Then there's the arch. So the arch, it's the one that kind of looks like a moon, with the construction is sort of above it. So it almost looks like a solid piece with a half circle cut out of it. Now the way the arch works is the load, is pushing on the top. So if this was my road, so I have my cars are going across here and they're compressing down on my bridge. And as it compresses, it spreads out the mass around the arch. So the highest point of compression is here, and then it gets lesser and lesser and lesser. So it's spreading that load over the arch. So it's not just in this one area as it goes across, it sort of disperses that mass. And then there's the dome. The dome is that solid shape. It's almost like, like putting a bowl on your head. That's the dome. And the way it works is the same way as the arch, except it spreads out the mass in the load in equal directions all the way around. So the load, when a load is applied, the mass is distributed equally all over the dome. So this is, a little bit less here, a little bit less here, a little bit less here. This is equal load all the way around. And that's how to make structures strong.